Hello. Hello, everybody. Hello. Or you can interact with me just before you start. If you know, there's a chat button on the left side of your screen. It's called the World Chat. So you can actually ask me any questions that you want over there in the World Chat. Just to make sure that it's addressed to me, you can actually write down Mr. Bottle and then ask the question, okay? And I'll try my best to answer because I have the chat room open as well. So feel free to ask me any question, but please remember to address it to me so I know it's for me, okay? Hello, I do see some of you. You can open your screen so I can take a look at you. Today we're going to do a science show, by the way. Yes. Who likes science? Okay, good, okay. Wow, just show me your screen so I can see you that you're reacting to the show if you can. For those who were looking at the other screen earlier, actually it looks like this. Oh, it's just an optical illusion, although the other screen looks like maybe a real Rubik's Cube. It looks like this. But actually, it is just a flat piece of paper. Yes. Okay, just to make sure all of you guys are ready for the show, let's warm you guys up a little bit because I have lots of gadgets to show everyone. This is my twin brother's Professor Messi's laboratory. So I'm Mr. Polo. I'm going to show you lots of cool science experiments, and he invented lots of cool things. And this is one of them. This measures the volume of voices. The louder you go, the higher this dial will go as well. How loud do you want to go today? 1 to 10? Who say that? Who say 9? 10, 9 or 10? 10 is way too loud. All of you will scream maybe until 7, okay? Let's see if you're all warm up. Including those who are muted. You can unmute yourself if you want to at this point, okay? So that I can hear you, right? Ready? I know there are different rooms today, so I'm going to take care of all the rooms, okay? Ready, everyone? Let me test this. Let me switch on. Test. Oh, it's working. Okay, all of you will scream Professor Messi as loud as you can, okay? Let's see if, who is the loudest. That's you, room 2, or room 3, all right? Ready? 1, 2, 3. Professor Messi. I think I heard someone say Professor Crazy. Who said that? Who said Professor Crazy? My name is my twin brother is Professor Messi, not Professor Crazy. Okay, one more time. Professor Messi, okay? Now, scream into that. Ready? Professor Messi. You're going to scream out loud so I can hear you, okay? Ready? 1, 2, 3. Professor Messi. Wait, excuse me. Who said Professor Silly? Do you say Professor Silly? No? Who was that? Room 2? Okay, let's try one more time. Okay, Professor Messi as loud as you can so you guys are ready, okay? One more time. You can unmute yourself, everyone. Ready? Professor Messi. 1, 2, 3. Professor Messi. Uh-oh. Who did that? Who broke my... Oh, boy. Well, I guess it's time to start the show now. And I have something very cool over here. Let's see. I'm going to use this cup. As you can see, this is a plastic cup. And I'm going to add some water to it. All right. This is water. I'm going to pour it in there. If you were here with me, I would ask you to actually touch the water, but just trust me, okay? This is real water. Now, do you think I can turn this cup of water upside down without spilling a drop? Who say yes? Who say no? Who don't know? Okay, let's see, okay? Ready? 1. Well, this is real water. It has not turned to ice, by the way. Yeah. Ready? 1. Wait, I think I better wear my safety goggles just in case. Yeah, in case it spill, yeah. I have this very cool safety goggle just for this. Yeah, in case it spill, I get the windshield wipers. See the water? Ready? 1, 2, 3. Did the water spill? It's still there, not even a drop. What happened just now? You all know? If you know, you can type in the chat if you want. Of course, anyone? Nobody? Well, this is a special force called the centrifugal force. When you turn something in a circle like this, there's an outward force which pushes the water into the cup. Yes, that's why the water stays in there. Well, if you don't believe me, you can try it at home. Just don't tell your mommy I told you to do this, okay? It can spill if you didn't turn it in a circle. It must always in a circle, or if you stop it suddenly, okay? Just to show you one more time, okay? Just turn it in a circle like this, and it works, okay? Now you can put it in a plastic bag and then tie it to the string. You just turn it around and round, okay? Okay, how about this? To prove that centrifugal force works, I'm going to go a step further. Maybe I'll put it in the cup. Just make sure there's nothing on the cup. Make sure there's no like tape, glue. Make sure there's nothing below it. There's no magnets on it. I'm going to put it on the tray. It doesn't work all the time. Okay, just let you know. See, the cup is separated from the tray, and I'm gonna spin it around. Let's hope centrifugal force works. Ready? 1, 2, and 3. The water's still there, and it is full. Yeah. Well, this works because of centrifugal force. Well, let's try this one last time. How about this? I'll make it even trickier. Let's see. I have a cup over here. Let me ask you a question. Let's see if you can answer it. Okay. Now, if I take a cup, this time I won't spin it. In other words, I'm just gonna turn it upside down. Do you think it is possible? Just like this, yeah, upside down. Who thinks it's possible? Say yes. No. Who thinks it's not possible? Well, with science, anything is possible. You need something extra, I must say. I'm going to take some water from here. I'm going to put some water. And I will need something extra, which is a piece of paper. Yes. Okay. Well, you can try this at home. Okay. Well, this is quite, I must say, quite tricky to do. Not easy. So if you're doing this, make sure you're doing it over a pail of water like me. Okay. See what happens as long as the weight of the water is not more than the atmospheric pressure that is holding on to this paper like this. Let me show you. See? This is real water. As you can see, the water will stay in the cup. And this is how you can turn a cup of water upside down without spilling a drop. But never remove the paper, right? If you remove paper, what happens? The water will spill, and then the water will go back on the floor. If you don't have a pail, just like me, see? Luckily, I have a pail, just like. Wait a minute. Hey, wait a minute. Hey, wait a minute. The water's still in there. Everyone, could you help me say gravity? Oh, gravity is a force that pushes the water into the cup. Ready? 1, 2, 3. Gravity. Let's see if gravity works. There we go. And that's how you do it. And talking about centrifugal force, you know that actually pharmaceutical companies can use the centrifugal force to separate things of different masses. See, those who have higher masses actually go to the bottom, and those items that are less dense will actually float to the top when you use centrifugal force. You can try this. You can try to mix up two liquids that doesn't really, mix together, and then spin it. You notice after a while that actually will separate. Yes, you can try it at home. Okay, now, this was like magic, isn't it? Talking about magic, who likes Elsa here? Anyone likes Elsa? Nobody likes Elsa? Yes, you? Okay, what? I love Elsa. What? Yes, I love Elsa. I do, yes. See, Elsa is pretty cool, isn't it? She can make snow just like magic. Yes, yeah. So it's pretty cool that Elsa can make snow and ice. Tell you what, I have an idea. I have a cup over here. Now, as you know, Singapore don't have ice or snow, but we can use water. The ice is made of water. All right. See, all I need to do is pour my water in the cup. You notice that instantly it turns into ice. And soon, even if I add more water, it just changes to ice. Well, some parts look like snow, isn't it? But does anyone knows what happened? Yes? Does anyone knows? Well, because what added a super absorbent polymer. Yes, what is that, you might think? Well, see, I added something that can absorb water very well. Well, you can't see maybe through the screen, but actually, once I add water to it, it expands 100 times the size. Imagine if it expands 100 times the size, what will happen? You will touch the sky? Probably. Well, that is what happened to this. And that's why you can see it now. But you can find this at home. Yes. If you have little brothers or sisters, they might have it. If they are wearing it, in fact, does anyone knows? Nobody knows? Oh, it's the diapers. Yes. Well, see, the diapers has this powder which is found in them. Once water is added to it, it does absorb all the water, so the water doesn't leak out. And this is the same item you can find in a diaper, so you can try it at home as well, okay? Well, I still have lots of gadgets to show everyone. And this is my next gadget. Well, this is my secret formulas and gadget. Inside this, it contains all my secret formulas and gadgets. Let me show you. Different formulas, different gadgets, different what? Different form. Yeah, that was empty. Did someone say empty? No, it has all my food. Wait a minute. This is my latest invention. It's called Eraser Security. You need to key in the secret password to get the secret formulas. But I cannot tell you because it's secret. Stop looking. Stop looking. I know you're looking, although your video is not on. Stop looking. 1, 2, 3, 4, 5. Believe it or not, with your secret password, which you don't know, I have access to all my formulas. The different formulas that I accumulated over the years, different formulas. No. What? How do you know my password? You see my password? Oh, I say it out loud. Okay, luckily you know my secret password for my secret gadgets. Now stop looking now. Password. Stop looking. Oh, those who just come in, stop looking, I know. 5, 6, 7, 8, 9. How do you know my password? Now you access all my secret. Oh, gadgets, different gadgets I claimed over the years. Oh, maybe we can try this one. This is pretty cool. Let's see. You can see this. Well, this is a very special magic one. It can be short, it can be long. That's my stay-at-home exercise for the day. So those who just come in, you can actually switch on your video so I can see you. Yes, all right. Okay, now this is very cool because of this. Listen carefully. Can anyone hear this? Yes, this is cool, isn't it? Why is there sound? Well, you notice what we learned just now? For centrifugal force, right? When you spin it in a circle, there's an outward force which pushes the water. In this case, it pushes the air. So when you spin it around like this, air has to be pushed out from here, and because it's hollow, it has to go in through the other side. And the air hit against the wall of this tube, which causes the sound. When this is how you hear as well, because of vibration in the air. In the ear, there's a eardrum, and when ear travels through the air, you can hear it when the drum vibrates. Well, to prove that to you, how about this? You can hear the sound, right? What if I'm gonna use a ziplock, right? And this time, I'm gonna put one end in the tube. Yes. In other words, air cannot travel in there now. Do you think there will be sound? Yes? No? Let's try. Let's listen carefully. Shh. There's no sound. Yeah. Air is needed to produce sound. So same thing, if I remove it again, there will be sound. In fact, if you feel it, you can feel the air moving in. I'm going to use a bigger tube. You notice that there will be a different sound. Because more air can go through it. It's a slightly bigger tube, different kind of vibration. If I spin it at different speed, that means different amount of air can go in as well. Yes, you can play music with this tube. Well, yes, you can use your mommy's washing machine. Don't do that, okay? Yeah, the tube. But you can find a tube that has special walls like this and try it, okay? Well, talking about air now, I have a question for everyone. Now, if I fill a balloon with helium and I fill a balloon with air, which balloon will float up into the sky? The one with helium or the one with air? You can type in the global chat so I can see. Okay? Yeah. Yes. Anyone? Helium or air? Nobody? Yes. Which one has more weight? Helium or air? Well, air has more weight, right? If you fill a balloon with helium, it will float up into the sky because air has weight. In fact, do you know that air takes up space? Yes. Yeah, imagine air around us, right? Making all different gases like oxygen, nitrogen, carbon dioxide. Yes, air has weight. Yes. If you fill up two balloons with air, and then you let go of one air from one other balloon, okay, and of course you balance them at the stick first, you balance them, and you let go of air from one of them, the one with air will actually pull it down because air has weight. What air takes up space, I'm going to prove using this. Yes, let's see. Who thinks you can blow up this balloon in the bottle? Who thinks I cannot? Okay, let's try. It takes a lot of energy to blow out the balloon in the bottle. That's why I keep my hand over the bottle. If not, the air will escape. Yes, escape. Yeah. So that's why I put my hand over the bottle. What? Sorry. Oh, hey, wait a minute. My hand's not over the bottle. Was my hand over the bottle? No? Let me see. Maybe something is blocking it. Let me get something over here. I'm going to put it through. Huh. Nothing. What's up? Let's see. What's happening here? Oh, what did we learn just now? Air takes up space. Well, if air takes up space, how do I blow out the balloon? Well, I cannot. If you don't believe me, take a balloon, put it inside a bottle like me, and try to blow it. You can probably blow just a tiny, weeny little bit, but not so much. How do I blow out the balloon then? Do you want to know the secret? Well, see, I actually made a little hole at the bottom of this bottle. Yes, there's a little hole in there to let the air out first. Now I'm holding on to that hole to prevent the air from going in. So how do I let go of the balloon? How to deflate the balloon? I can let go of the bottle. Let's see if it works. Aircon. Okay. Now, talking about balloons now. Who likes balloons? Well, I have some balloons over here. Let me try to blow out one balloon. Ouch, sorry. Okay, we'll blow out one balloon. As you know, balloons are made of. Made of. What is it made of? Ouch. Yeah, it's made of. Yes, rubber. As you know, balloons are elastic. Ouch. Elastic. Now you can stretch it. You notice it will return to its original shape. Yeah, as long as its elastic point is not being reached, it will return to like this. Sometimes it might stretch a little bit if the elastic point is being reached, and sometimes you will stretch it and doesn't go back again, right? Have you tried before on rubber bands? Well, I'm going to just use this to prove it, okay? What? Sorry, what do you say? We're going to blow out the balloon. What? Sorry? You can't hear me? No, we're going to blow out. Stop laughing. We're going to blow out the balloon. What? What's so funny? We're going to blow out the balloon in the air. Stop laughing. Okay. I guess, just for safety, I think I better wear my safety goggles as well. Let me get my safety goggles. Well, every scientist has to be very careful to make sure that we don't do dangerous things when we do our experiments, okay? What? Not so funny. Whoa! Oh, that's my reading glasses. Let's see. Oh, there is my safety goggles. Okay, now we are ready. Okay, now again, what's so funny? Hey! Oh, I am hearing hypnotized. Whoa, 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 whoa. Oh, okay. Oops. Sorry about that. Oh, sorry. Wrong safety glasses just now. I can wear my safety glasses. Okay, now we are ready. Okay, now we can. What's so funny? That's my vacation glasses. That's not it. Oh yes, my safety goggles. Phew. Oh boy, that was silly. Oh, safety goggles. Okay, let's try to roll. No. Are y'all ready? What? Okay, there we go. All right, let's tie the balloon. Okay, now, if I'm gonna use this, I have over here, needle. Do you think the balloon will pop? It's still a normal balloon. Let's hope it works. You put it in there like this. You can see the needle going through it. Wow, What is happening here? Why didn't the balloon pop? Is this a real balloon, some of you may ask? Let's try it. Let's see if it's a real balloon, okay? 1, 2. Yep. Oops. It is a real balloon, I guess. Okay. Now. Phew. That was scary. Now, does anyone knows what is the use for alcohol? Well, I know every day you might use it in school even now. You all know. Everyone knows. Type in the chat or can unmute yourself and say, I can see you, actually. Anyone knows? Well, you can use it because now we're having this virtual family day, right? Well, because of COVID-19, and because of that, we got to pay attention to our hygiene. And we use alcohol to actually for our hand rub, a sanitizer. Well, alcohol is effective to kill virus because it can break down the protein in the virus. Today, we're going to use alcohol for an experiment. Very cool experiment. Sometimes the alcohol that you have, the purities might be different, so it might work, not work. I use this. This is rubbing alcohol. Okay, you can find in a pharmacy. All right, this is pretty cool. I'm just going to put some in a bottle. Not me, in this bottle. You see? Okay. Now I'm going to increase the pressure of this bottle. Okay, how I'm going to do that is using a pump. Yes, a pump. Yes, I'm going to hold it like this. Like this. Okay, I hope you can see it. Increase the pressure like this. Okay, and this will slowly increase pressure. Oh, I released it too early. We try it one more time. Okay, all right. I want alcohol rub on my. Okay, one more time like this. I'm gonna increase the pressure. I'm gonna release in just an instant. You see, it becomes smoke. See, by increasing pressure, the water vapor actually condenses at a low temperature, and that's what happens. Okay, and then of course the alcohol molecules evaporate pretty fast and condenses inside this bottle. We'll try it one more time for those who miss it, so you're gonna look very, very carefully. Okay, and this is gonna be our last experiment because we are almost out of time. One last try. Okay. But if you're doing this, please ask your mommy and daddy to help because when increasing the pressure, it does have, okay, just in case, okay, in case. All right, one last time, because I didn't hold it properly just now. Because when you ask your mommy and daddy to help, because I don't want anyone, a bottle flying off into anyone's face, it's very important you hold it properly. All right, the pressure is built up inside, and we're gonna release at 3, 2, 1. You see the smoke inside. You can pour the smoke. You see the smoke? Yes. Cool, right? So you can try all these experiments at home, and that's all the experiments we have for you. I'm Mr. Bottle, representing Professor Messi. I hope you enjoyed today. Thank you so much for joining in. I hope you learned something today. So if you have any questions, you can feel free to actually type in a comment. I'll still be in that chat, okay, for just next 5 minutes. So if you have any questions, ask me, just type it in, and I'll see you in a while. Thank you. Bye-bye. Bye-bye.